Hello friends, welcome again to the lecture series of the communication system. In this lecture, I am going to discuss about the demodulation of AM signal, especially double sideband suppressed carrier. So, in the case of the demodulation, the first technique is coherent detector. So, in case of coherent or synchronous detection, a carrier at the receiver is used to detect the message/information signal. So, see this particular diagram where we use a product modulator and a local carrier, that is cos omega ct. Omega is 2 pi fct. Both are multiplied in a product modulator, and then the output is passed to a low pass filter. So, see this particular the block diagram. In the case of double sideband suppressed carrier modulation, we required a product modulator and a band pass filter. Here we required a low pass filter. So in case of double sideband suppressed carrier, wave is applied to a product modulator in which it is multiplied with locally generated carrier cos omega c ft. We assume that this locally generated carrier is exactly coherent or synchronized in both frequency and phase with the original carrier wave used to generate a double sideband suppressed carrier wave. This method of detection is therefore called coherent detection or synchronous detection, because the carrier used for the demodulation of the message signal is same as the carrier used for the modulation of the message signal. So this method of detection is therefore called coherent detection or synchronous detection. The output of the product modulator is applied to the low pass filter, which eliminate all unwanted frequency component and produce the message signal. So in the case of the coherent detection, the output of the local carrier oscillator is given by cos 2 pi fct is phi. Actually it is the phi is equal to the 0, but here for the sake of convenience, and we know that we are not able to if you generated a carrier with a device, there are some phases shift is present. So to consider this phase shift, they are taken cos 2 pi fct plus phi. Otherwise, in ideal case, phi equal to 0 and this ct is equal to cos 2 pi fct. So thus the amplitude of the signal is 1 and the frequency is fc. The phase difference is equal to phi. So the output of the product modulator is given by st multiplied by c dash t. What is the st? St is equal to xt ec cos 2 pi fct. And we know about the carrier c dash t. So we multiply both the signals, so it become xt ec cos omega ct plus phi into cos omega ct. Then we know that trigonometric equation, trigonometric formula cos A cos B. So by using this formula, we have changed this cos 2 pi fct plus phi into cos 2 pi fct phi. It's become 1 by 2 cos 4 pi fct plus phi plus cos phi. So that is my final equation. So you see this. If we break this equation, then the first equation is become 1 by 2 xt ec cos phi. That is the scaled version of the message signal, plus 1 by 2 xt ec cos 4 pi fct plus phi, that is unwanted term. So the above equation show that output of the product modulator consists of the two terms. The first one represents the message signal with an amplitude 1 by 2 ec cos phi, hence this is the wanted term. This scaled version of the message signal is a wanted term, and second one is the unwanted. So after the passing the low pass filter, the second term will eliminated and only first term will remains. So the V naught t is equal to 1 upon 2 ec cos phi into xt. And so one more thing, if we consider ideal signals and the phi equal to 0, so we know that the cos phi equal to 1. So it's become V naught t equal to 1 upon 2 ec into xt. 1 upon 2 ec, or ec by 2 is a constant term. So it is the basically scaled version of the message signal what we have already written in the top. So scaled version of this message signal is xt. Thus the output of the coherent demodulation is proportional to the message signal st if the phase error cos phi is the constant. So only distortion introduced in the system, if we need to generate a carrier which has the same frequency and phase. If there is any deviation present in the frequency and phase of the generated carrier at the receiver, so it's introduced the error. So that is all about the coherent detection. So what are the advantages of this synchronous AM detection, that is also called coherent AM detection? So that is basically it's reduce the effect of selective fading, then it's reduce the level of the distortion. Similarly, it improved the signal level and it's also improved the signal to noise ratio. So what is the fading? In wireless communication, you know about detail about the fading, but fading is actually related to the shape of the signal. So basically it is a shape distortion, and similarly a level of this reduced level of the distortion, because there are level on the basis of that we are able to recover a message signal, that is called basically the threshold level. So if this level is reduced, we are not able to recover our signal from the noise. That's why the last point is improve signal to noise ratio. So that if the signal to noise ratio is nothing but signal power to the noise power, so if the signal to noise ratio will increase, it automatically means the signal power will increase. Then we move the single sideband modulation. So in the case of single sideband modulation is basically a derivative of amplitude modulation by removing some component of the ordinary AM signal. It is possible to significantly improve the efficiency. So the standard AM and double sideband suppress carrier technique. So there are again wastage of the bandwidth required for a standard AM is large, bandwidth required for the double sideband suppress carrier is small in comparison to the AM signal. But even for a transmission of a signal from one point to another point, if you consider, then their bandwidth is large. And similarly, in both the case, the transmission bandwidth is occupied by upper sideband and lower sideband are uniquely related, and information is present in both the sideband, upper and lower. So in this particular single sideband case, what we can do, we can transmit only one sideband and suppress other sideband, so that a more saving of the power is possible in the case of single sideband modulation. So it is possible to suppress the carrier and one sideband completely. When one sideband is transmitted, the modulation is called a single sideband. So we choose either the single sideband or double sideband transmission of signal. So see this particular diagram. The first diagram is a message signal spectrum. It is a frequency domain, so that's why we call here the spectrum. So after the modulation, we see that our new spectrum, that particular spectrum consists of upper sideband term and lower sideband. See, there are transmission from the G center frequency to upper frequency plus FC and minus FC. Then if one sideband is removed, we have removed the lower sideband in that particular case. So the third diagram is, so see that spectrum of double sideband suppressed carrier with only upper sideband. Then we have also possible to remove lower sideband. So the D, that is the spectrum of the double sideband suppressed carrier with only lower sideband transmission. Then again we have discussed about the single sideband modulation. Power consists in the case of the single sideband modulation. So see here, in the case of the single sideband modulation, either the upper sideband or lower sideband is present. In the previous equation, we have also know that upper sideband is nothing but AM AC upon 2 cos 2 pi FC plus FMT. Similarly, in the case of lower sideband, FC minus FM, that is called the lower sideband, and power is simple AM AC upon 2, and transmitted power in that case, transmitted spectrum consists of only either upper sideband and lower sideband, no carrier power, and one sideband. It means our transmitted power is nothing but AM square AC square upon 8 R. We already know that, you people already know that how we got AM square AC upon 8 R by the calculation of the power consists in the sideband, or total power consists in the spectrum. In the previous double sideband suppressed carrier and standard AM signal, I'm already calculated this. So from this term way we are able to calculate what is the transmitted power. Then what is the transmission bandwidth is required? Transmission bandwidth is required here, see here FC plus omega minus FC. So FC is cancelled, it is the omega. Similarly FC minus omega, omega. It means in the previous case 2 omega bandwidth is required, but here only omega bandwidth is required. So this is exactly half of the bandwidth of double sideband suppressed carrier. So it is the half of the bandwidth is reduced. So that is the one of the advantage. Then there is another advantage is, first less bandwidth is required. So the more number of the channel will accommodated in the same frequency range. Then there is the power saving. So if you calculated the power saving in the case of the single sideband, so it's around 83.3% power is reduced due to the suppression of carrier power and one of the sideband power. Then interference, reduced interference of the noise. This is due to the reduced bandwidth. If bandwidth is reduced, then interference will reduce. So the noise due to interference will also reduce. As the bandwidth increases, the amount of noise added to the signal will increase. So the signal to noise ratio is improved. Then disadvantage, the first disadvantage is circuitry is very complicated. Circuitry is required for the generation of a single sideband. Then we require excellent frequency selectivity, stability. Then SSB is not generally used for transmission of good quality music. It is used for speech transmission, because the losses in the speech is not recognized by our ears. So we use it for speech transmission, not for the music. Then application of SSB transmission use application where power saving and low bandwidth requirement are important. This application area: land mobile communication, air mobile communication, telemetry, military communication, navigation, and amateur radio. Many of these applications are point-to-point communication. So in short, point-to-point communication we may use the single sideband modulation, but in the case of music we are not use this single sideband modulation. Then in the next lecture we have discussed about the different method of the generation of single sideband carrier.